Hello friends, I am Aher from RBNB College Rampur from Physics Department. Today we study the chapter Superposition of the waves. In this chapter we study the stationary wave and the properties of stationary wave. You find or we determine the condition for nodes and antinode. The condition for nodes, that is node, the point at which the displacement is 0, the points are called as node, and the node is formed, that is the resultant amplitude is 0. That is resultant amplitude is 0, that is 2a cos 2 pi x upon lambda is equal to 0. Therefore 2 pi x upon lambda is equal to, we take, that is it is pi by 2, 3 pi by 2, 5 pi by 2, etc. Then x is equal to lambda by 4, 3 lambda by 4, 5 lambda by 4. That is the nodes are formed at lambda by 4, 3 lambda by 4, 5 lambda by 4, etc. The distance between two successive nodes, it is lambda by 2. Difference between the two x, that is 3 lambda by 2, 3 lambda by 4 minus lambda by 4, it is lambda by 2. Thus we can say that the distance between two successive nodes, it is lambda by 2. Now then we see the condition for antinode. Antinodes are the point at which the resultant displacement, resultant amplitude is maximum. That is 2a cos of 2 pi x upon lambda, it is maximum, that is it is equal to plus or minus 2a, that is it is plus or minus 1. Therefore 2 pi x upon lambda is equal to plus or minus 1. The angle is plus or minus 1. It is for angle pi by 0, pi, 2 pi, 3 pi, etc. Then we find the value for x. It is, see, the values are 0, pi, 2 pi, 3 pi, etc. And the values are, the values for the antinode, it is 0, lambda by 2, lambda, 3 lambda by 2, etc. Now we see some properties of the stationary wave. The stationary wave, it is loop-like structure and they are having the property, the stationary wave, it is two identical waves, two identical progressive wave having same magnitude, same amplitude, but traveling along the same path but in the opposite direction, forming a stationary wave. Here we have two identical progressive wave traveling along the same path but in the opposite direction, forming loop-like structure. It is called as stationary wave. Then we see the stationary wave, it is look like these loops, and we see the properties of stationary wave. The two identical progressive waves traveling along same path but in the opposite direction, forming a loop-like structure, forming a stationary wave. Now see, there are two progressive waves. Suppose this is one progressive wave and this is incident here, that is at this is the denser medium, it is reflected back and interfere with each other by the superposition of the waves, forming a stationary wave. Now in case of, there are two types of stationary wave, the transverse stationary wave and longitudinal stationary wave. In case of, suppose we can say, in case of transverse stationary wave, transverse stationary wave, transverse stationary wave. See, these waves are produced on the string, and suppose this is the one string, it is reflected back and loops are formed. These are the transverse stationary wave. When the transverse stationary wave propagated or seen on this string, it shows there are some points. There are here two identical transverse wave, two identical transverse wave, traveling through medium, along the same path, but in the opposite direction, forming a transverse stationary wave. When the transverse stationary wave, it is like this, then there are some points, where the resultant displacement or amplitude is minimum. The points are called as nodes. Here see the points, the amplitude is minimum here, and the amplitude is minimum which are at the rest, and the points are called as nodes. The distance between successive nodes it is lambda by 2. Then there are some points where, see, there are some points where the amplitude is maximum. The points are called as antinodes. See, here the points having maximum amplitude, they are called as antinode. Now, the distance between two successive antinodes is lambda by 2. When this transverse wave propagated on the string and it is the medium divides into alternate see node and antinode. Then we can say nodes and antinodes. Nodes and antinodes. Antinodes are alternately placed. Alternately placed. See here, there is node, then antinode, node, antinode, node, antinode. That is, nodes and antinodes are alternately placed. Now, in case of longitudinal stationary wave. Longitudinal stationary wave. Longitudinal stationary wave. Two identical longitudinal progressive wave traveling through medium interfere with each other, but they are in the opposite direction, forming a longitudinal stationary wave. For example, we consider the resonance tube. In this case, there is a formation of longitudinal wave. Now, then when there are some points where the amplitude is minimum, the points are called as node. The amplitude is maximum, the points are called as antinode. That is, we can say that when at the antinode the intensity of sound is maximum, at the node intensity of the sound is minimum. Here the distance, that is the distance between two successive nodes, it is also lambda by 2. Distance between two successive antinode, it is lambda by 2, and the distance between adjacent node and antinode. Node and antinode, it is lambda by 4. It is lambda by 4. Now, in this case, stationary wave, when stationary wave localized or it having the velocity 0, it having velocity is 0. Thus, there are the nodes and antinodes are produced. The amplitude of vibration varies periodically in space. All points vibrates with same frequency. Then the resultant velocity, all particles are, see here adjacent node and there is the distance, or node and antinodes are formed, and the distance between node and antinode is lambda by 4. Now the velocity, the resultant velocity is 0. In this expression or in stationary wave, the term x upon lambda, it is absent. That is, the wave do not travel to the plus x direction or not to travel minus x direction. The resultant velocity is 0. The wave is localized. The wave is localized, it does not propagate through medium. It is called as stationary wave. It is also called as standing wave. These are the properties of stationary wave. Now we consider the next topic, or distinguish between the comparison of the stationary wave and progressive wave. Comparison of stationary wave, progressive wave and stationary wave. See here, progressive wave, and stationary wave. The progressive wave, the wave traveling continuously in a given direction. The wave travels continuously in a given direction. It is progressive wave. Here two identical progressive waves traveling along same path, but in the opposite direction, forming a stationary wave. Here the progressive wave, it is the oscillatory disturbance traveling through medium. This wave does not propagate. Propagates through medium. See, there is energy is transfer here. Energy is transfer from particle to particle. Here energy does not transfer. At some points, that is node, energy does not transfer. These are some comparison points, that is for progressive wave and stationary wave. Now we see the harmonic and Aher tone. Harmonic and Aher tone. See, suppose we consider a string, it is fixed into support, and suppose this is stationary wave is formed. Then what is harmonic? Suppose this mode consists of number of frequency n, 2n, 3n, 4n, etc. Now what is the harmonic? The harmonic it is called as first harmonic. It is called as second harmonic. It is called as third harmonic. And so on. These are called as first harmonic, second harmonic, third harmonic, fourth harmonic, etc. N is the fundamental frequencies. That is integral. We can say that harmonic is integral multiple of the fundamental frequency. Harmonics it is the integral multiple of fundamental frequency. Any mode consists of the frequency n, 2n, 3n, 4n, etc. 1n it is first harmonic, second n is the second harmonic, third n is the third harmonic. Now we see the Aher tone. Now see, these are the n frequency 2n, 3n, 4n, etc. Now this is called as first Aher tone. This is called as second Aher tone. That is the frequency. We can define the Aher tone. That is the frequencies immediately higher than the fundamental frequency. It is called as Aher tone. Thank you.